Well, good morning. Thanks for coming out. I know it's early, especially after the party last night. I hope you guys enjoyed Dylan and the Line Breakers and Love Shack. I know I did. But we're here at NDC, so let's break some things. I want to look at some security holes that we've had in the Git project and how they could have been exploited to perhaps get into your code. Real quick introduction. My name is Edward Thomson. I'm a program manager at Microsoft. I work on the Visual Studio Team Services team. My focus is Git and version control. I'm a PM now, so most of my job is spent in Outlook or in PowerPoint. But before that, I was actually a developer. I worked on Git tooling at GitHub, at Microsoft. I worked at SourceGear before that. So I've been in version control for a really long time. So I've worked on a variety of version control tools on a variety of platforms. But now my focus is on Git. Microsoft is pretty much all in on Git at this point. So that's my day job. At night, I have a podcast called All Things Git, where we talk about neat things in the Git project, including these security vulnerabilities. And aside from that, I have more stuff to do at night because I don't like spending all of my time in Outlook and PowerPoint. I'm a maintainer on an open source project called libgit2. We'll talk more about what libgit2 is in just a second, but high level overview. It's a re-implementation of Git. So it is a linkable library that you can use to put Git into your application. So if you were building a Git client like Git-Kraken or Gmaster, and you didn't want to run the Git commands on the command line, then libgit2 might be a really attractive alternative because it's just a linkable library that you can use. And there are a bunch of language bindings. So if you want to write Ruby or .NET, you can use Rugged or libgit2 Sharp, which talk to libgit2. Building libgit2, we took a lot of the actual source code out of Git to make it. Git, if you've ever looked at the code, is a mix of C and Perl and shell scripts and all that fun stuff. And so that doesn't really lend itself to embedding inside an application. So libgit2 takes some of the code out and modularizes it, makes it nice, but it shares a lot of the same origin as Git. So it is written in C like much of Git itself is. C is, I think, an incredible programming language. It's my favorite language to write in. There's some great reasons to write an application in C. First of all, it's very powerful, right? You can get right down to the metal. The only thing better is writing assembler, so it's kind of like an abstract version of that. Incredibly powerful. If you want to write a kernel, you're going to do it in C. If you want to write a device driver, you're going to do it in C. The other great thing about C is it's really fast. The reason it's fast is because it doesn't do things like bounds checking on arrays or checking on integer overflows, which leads us to reason number 3 that you should use C. It's totally secure. Nope. Actually, no, it's not. There is no reason 3. The reason that C is so fast is because it eschews these things like checking on conditions for overflowing arrays. So if you allocate, I don't know, a megabyte, and you try to read 2 megabytes of a file into it, C will let you. .NET might crash, some languages might resize arrays. That's all great. C will just totally let you overwrite that memory. And then you can come back and reference it later. So if you expect to have 1 megabyte's worth of file and an attacker gives you 2, well, now they're writing into places in memory that you didn't expect them to. And so they might be able to stick some code in there that they could then execute. So C really is a great programming language, but you've got to be incredibly careful with it if you're going to build applications in it. That's especially true if you're building a version control application that everybody relies on. There are lies, there are damn lies, and then there are statistics. But if you'll bear with me, this is the data from the most recent Stack Overflow survey of professional developers. And it shows that 90% of professional developers use Git at some point in time. Maybe that's not the only version control system they use, but almost all of us use Git at some point or another. So it's pretty important that we get this right from the Git community's perspective. You know, the next runner-up is Subversion, also written in C, I might add. And Team Foundation version control is squeaking in at number 3. So there's a pretty important security aspect that we need to consider on the Git project, because everybody uses us, right? Financial institutions use us, like Thomson Reuters and PayPal, the NASDAQ, the stock exchange, actual market uses Git. The Air Force, NASA, things flying around and going into space use Git. So if there's a security hole in Git, that could be really problematic if an attacker could get into your code, right? That's sort of the nightmare doomsday scenario for me, is somebody coming along and being able to figure out a way using Git to get their source code into your project or to run code on your computer. I said that this was, important to me. That's because I'm the maintainer of the libgit2 project. You may not have ever heard of libgit2, but we've heard of you. We're used in a variety of hosting providers like GitHub, GitLab, Bitbucket, and Visual Studio Team Services. So if you're putting your code into a hosting provider, it's probably using libgit2. I worked on a function in libgit2 called merge. And almost all of these providers use libgit2 and its merge functionality when you click the complete pull request button. So my code is changing your repository. So this is really important to me that we get this right, because if there was some way to run arbitrary code or to add arbitrary code to your repository, that would be really terrible. The first stage at which we look at security is, of course, doing the pull requests. So libgit2, we use GitHub to manage the project. And so we're very careful about reviewing every pull request that comes through, looking for things like buffer overflows, integer overflows, and that sort of thing. The Git project itself doesn't use GitHub. Git started as a project from Linus Torvalds. He likes to use a mailing list for development. He, of course, is building the Linux kernel. And so there's the Linux kernel mailing list. Similarly, there's the Git mailing list, and that's where Git's development goes on. But they are no less strict about looking at what comes into the repository. Of course, they're human. I'm human. As developers, we're human. We all make mistakes, sort of mistakes that lead to security vulnerabilities. And we make mistakes when we're reviewing code and miss things. So thankfully, there are tools that we can rely on to help us. We use Valgrind, which is good at detecting memory leaks, yes, but also out-of-bounds execution and out-of-bounds reads. But Coverity is an outstanding tool. Sorry, it's not an open source tool, but they do have a free tier available for open source projects. And it finds a ton of things that might be able to be exploited as security vulnerabilities. But interestingly, it's not really the buffer overflows or the integer overflows that are usually the problem here. Generally, it's assumptions. Let's put a pin in that for just a second and talk about the operating systems that we use when we are building software. There's 3 big ones: Windows, Mac, and Linux. And if we look again at that same set of lies that is a statistic, we'll see that Windows is still the most popular desktop in use by software developers. It's got the lion's share of the market. Even when you go to Silicon Valley, all you see is Macs, and still somehow, at least the respondents of this survey, are not big Mac users. And Linux actually shows up. So this isn't the year of Linux on the desktop, but since it shows up on this graph, you know it actually is software developers. But there's an interesting thing about Git. Like I mentioned, it was built by a guy originally named Linus Torvalds. Linus built the Linux kernel, of course, and he built Git to support the development of the Linux kernel. So a lot of the Git developers actually came out of this background with the Linux kernel mailing list. So most of the people who actually build Git, the command line application that you run when you do version control, are Linux users. And so that leads to some interesting assumptions. And in particular, it led to one called CVE. So we don't give fun names like Shattered or Heartbleed. We don't give fun names to our security vulnerabilities on the Git project. So we just call them by their CVE. A CVE is a common vulnerability, and exposure, I think, is the E. So when you have a security bug in your project, you register for a CVE with a clearinghouse that assigns numbers. And so they just give you a number. The first part is the year. So this happened in 2014. And then the next is just a monotonically increasing number. So the first big security hole in Git was CVE 2014-9390. I can recite this in my sleep because this was such a problem for us at the time. Let's take a look at what it involves. So I've got a Git repository here. It's a pretty simple repository. It's just got one file in it. And I've got this .git folder here. And that's actually what makes up my Git repository. So if you were here at NDC Oslo last year, I unpacked what was in this repository. So you can check that out online. I don't want to rehash all of that. But if you've never looked inside your .git folder, let me just give you a brief rundown on a couple of important things. First of all, your branches are in here. There we go. So they're in a folder called .git/refs/heads. So I've got a branch called master. And that is just a pointer to my to the Git object that branch points to. I've also got a folder in here called objects that you can see. Let's take a look in there. So I've got a bunch of folders, and most of them are just 2 hex characters. And let's look at what's inside one of those folders. Right. So this is actually a Git object. A Git object is either a blob, which is a file that I've added to my repository, or it could be a tree, which makes up the hierarchy of my repository, so it's a directory. Or it could be a commit, which is the information that gets stored when I run git commit that points to the tree in question. And Git takes the SHA-1 hash of the contents, and that's what you see as the object ID. It's that 40-character hexadecimal number, in this case, F9, FC, F0, yada, yada, yada. And it stores it inside the Git repository. So if I look in here, it's just actually a compressed version of the commit or of the file that got checked in. And that's actually the contents of your Git repository. When you run git clone and you quote unquote get a full copy of the history from the server, this is where it's stored, here in .git objects. It would be bad if I could write into that, right, as an attacker. That's my data. And so Git goes and takes special precautions so that you can't write into the .git folder. If you ever run git status, you won't see all these files in .git. That's Git's place. You can't touch it. If you run git add on a file in here, Git will refuse to add a file because you can't check something out into that directory. Again, that's Git's place. Okay? Right. So this is pretty straightforward so far. So let's check out a different branch. Okay? And let's see what's changed. Well, still just got this file called hello.txt, so it looks like not very much has changed. But let's dig a little deeper. Right, well, let's take a look here inside my Git folder. I've got a new file called hellorepo.txt. That wasn't there before. How did we get it there? Well, let's take a look at the file first, just to make sure it's not some Git metadata that we we didn't notice before. .git hello repo.txt. Oh, hello Git repository. It looks like it's coming from inside my repository. Okay. So what we've actually done is we've switched branches, and we figured out a way to write files into the .git folder that we're not supposed to be able to. Okay. If we look at the head tree, if we look at the contents of head, you might get some insight into how we got here. So I've got this folder. I've got a tree inside my repository that is .git all uppercase. Remember when I was talking about assumptions, and remember when I was talking about the fact that most of the Linux developers, most of the Git developers use Linux? You might be piecing together how we got here, right? So let's look at the .git folder, .git all caps. Aha, yes, it's got a blob or a file called hello repo.txt. So what Git has actually done is it's opened up .git all caps hello repo.txt, and it's written that hello Git repository. So what's happened here is that Linux is a nice case-sensitive file system, while Mac and Windows are case-insensitive but case-preserving. So when you open up .git all caps on Mac and on Windows, you get the .git folder. And Git, at least old versions of Git, pre-2014, didn't think about that and didn't check for that. So they would happily allow you to write files into the .git folder using this all caps. So an attacker could give you a repository that you could then, just running Git commands and not any of their own code, get files placed onto your computer surreptitiously. So that's sneaky, but could we exploit that? Could we actually take advantage of the fact that Git, that we can put files into the Git directory in order to trick you into, I don't know, executing code or something? Well, could we change files in your repository without you knowing it? Let's take a look. Right, so first things first, let's try to attack this. Okay, so if I switch back to my master branch, let's take a look at the contents of hello.txt here. Right, so it says hello world. Now, can I figure out a way to change this file without you knowing it? Can I sneak in something that might pass code review and changes this file? Maybe I could use this to change a source file without you even knowing it, without seeing it in a diff view, just by changing the contents of the .git directory. Right. Well, I have a branch here called replacement object that I'll check out. And when I do that, it gives you a really scary warning. The following untracked working tree files would be overwritten by checkout. And it gives you this crazy file name that's obviously in the .git directory. Now, most people would be frightened by this and decide to give up and run away correctly. But some people will could be perhaps socially engineered. Hey, I really need you to code review this change. And if they weren't familiar with Git, they might look at this and throw up their hands and do what everybody does when faced with a Git error message that doesn't make any sense. They would go to Stack Overflow. And they would post a question like, hey, I got this error message. The following untracked working tree file, yada, yada, yada. And they might think, well, I don't want to give away this file name. That might be important, so I'll sanitize it. You see this a lot on Stack Overflow, where people have carefully edited the question so that they don't, give away any personal data. And then the reply might be, well, if you don't care about that file, then what you want to do is run reset -- hard. Here are some steps. I can git checkout to create a new branch, call it replacement object, And now I can reset dash dash hard to point to the origin replacement object. Great. So now I've checked out that branch. Reset dash dash hard will force the checkout, and it will allow me to overwrite those quote unquote untracked working tree files. Okay. So now what? Well, now I don't have that hello world anymore. Okay. But I have done something a little bit evil. So I've removed the hello.txt, and I have, let's see what's in head. Oh, clearly I've done something with the .git directory. And if I take a look at this, you can see that I've added an object. Let's look in that tree. AF 9A. Right. So I've added .git objects AF5626. Again, this is an object which has a blob, and that's the SHA-1 of its contents. It turns out that that's actually the SHA-1 of the hello.txt that's in my master branch. So I'm overwriting the object file with my own data. And looking at the diff, looking at the actual Git repository, you'd never know that I was changing hello.txt. You would only think that I'm changing this random file called .git objects af yada yada yada. And that's okay because this is a SHA-1 and that's a hash, and so we should be able to validate when we actually do file operations on this object that it corresponds to what it is, right? So if I tried to, say, put that object back on disk, Git would surely complain, right? Yeah, let's take a look at that. Right. So right now I'm on this branch that has introduced this object, but I want my hello.txt back. So I would do the very logical thing and merge that branch into master. So now I've got hello.txt back. We can see it's right there on disk, and surely it's the same hello.txt that it was before that just says hello world. And no, it's in fact not. So if we look back at the history of Git, again, it was built by Linus Torvalds. It was very much influenced by a project called Monotone. And Monotone introduced the directed acyclic graph. It introduced Merkle trees. And it introduced SHA-1 as the hash for file contents. And every operation that Monotone did validated SHA-1s. It was very important to make sure that there was no corruption and that there was no data integrity losses, is perhaps the most polite way to put this, caused by your version control system. And so Monotone validated SHA-1s at every operation, and it was painfully unusably slow at the scale of the Linux kernel. So Git doesn't. Git does this when you push or when you pull, when you basically are bringing objects into your repository. It will validate the SHA-1s then, but once they're there, surely you couldn't tamper with them, right? So we're able to take advantage of that and bring code into this repository, bring files into this repository surreptitiously. Okay. So if I check out my master branch, that's still true. So I was able to poison the object database in this Git repository just by having you merge a branch, right? So that's a pretty big deal. But you might still notice this. You might catch this. And it's changing a file on disk. It's not remote code execution. Could we get remote code execution out of this? Well, let's take a look. So I've got a branch here called hooks. And okay, so I've switched to this branch, and now I'm just going to do, I don't know, some normal developer things. I'm going to add a file. This is a new file, and I'm going to commit it. Oh, didn't expect that to happen. Just by running git commit, I've got this random dialog box popping up. my repository is telling me that it can run arbitrary programs. That's not right. Right. How did we do that? Let's git diff master and take a look. Right. Well, I've added this file called .git, all caps, hooks, pre-commit. So Git has this system called hooks, which are programs that you can add to your Git repository that can run throughout the Git workflow. For example, there's a pre-commit hook, which runs to validate your commit. You could put stuff in here like a linter or something to validate that the code you're about to commit is of high quality. But you can't add this to the Git repository, right? Like your configuration, hooks are something that you have to add yourself, because you wouldn't want to git clone a repository and then have it suddenly running a bunch of scripts that you didn't write, that you don't have any control over. So Git is very careful to make sure that you can't add pre-commit hooks, at least normally. So by going through this .git all caps system, an attacker could give you a hook that then runs on your system. So that's not ideal. So again, this was CVE 2014-9390. And so it allowed a couple things. It allowed an attacker to put code potentially into your repository or execute arbitrary programs through the hooks mechanism. And so basically, the way Git was protecting its repository itself was doing the moral equivalent of strcomp.git. If you're not a C person, this is actually just doing a string compare on .git, all lowercase. And so the naive solution to this problem is just stir casecomp, which does a case-insensitive comparison on the .git directory. And that should work, right? So before we were protecting the .git folder. And by moving to stir casecomp, we protect all variations of .git. .lowercase git, .uppercase git, mixed case git. We've got them all. Surely there's no way to go around this, right? Well, let's take a look at Windows real quick. So here I've got the same evil repository, and this time I'm on Windows. So let me run git branch. So I've still got hooks, and now I've got two more folders called winhooks and winhooks2. Let's check one of those out. Okay, great. And now let's do the same thing as before. We'll look inside our repository. We'll add a new file. Pardon me, I really like VI. And I'm going to add this file and commit it. And just like before, we get a dialog box popping up. This time I'm using VB script, but could be anything. How did we do it this time? Well, we've done things a little bit differently, because I've taken the patch to do the stir casecomp. So I'm protected here against .git uppercase attacks. So let's look inside our repository, and here I've got .git/hooks/precommit. Windows is famously backwards compatible. And to the point where Windows 10 has some of the same file system semantics that DOS had. If you remember DOS, it had 8.3 file names. You had up to 8 characters in the beginning, followed by a dot, followed by, at most, 3 characters as a suffix. So you'd get things like readme.txt. Great. The thing about 8.3 is you didn't have to have that .3. You could just name a file readme. And in DOS's muddled thinking, its addled brain, readme and readme dot were the same thing. It was a file with no extension. So you could say, open readme dot and get readme. So basically, DOS and now Windows, even Windows 10, will look at a dot at the end of a file name and ignore it. Same is true as a space. So you could add a folder called .git to your repository. And when you call create file, which is the Win32 system call, when you call create file .git it'll open the .git repository. So here's another fun way to get into the Git repository, okay? So let's take a look at this other branch, winhooks2. I'm going to check it out, and when I do, even just checking this branch out, I've got this dialog box popping up. We're taking advantage of a different hook. It's sort of the same idea, but this one runs when I, as the post-checkout process, when I put files on disk. So switching branches invokes a checkout, files get put on disk, and the post-checkout hook runs. Well, that's neat. How are we doing this one? Let's look at my repository again. And this time I've got git ~1. Y'all look quite young. You may not remember. Again, in the bad old days of DOS, file names were 8.3. And then when we moved to long file names, we needed some compatibility story for those poor people still running DOS. Who wanted to be able to mount a volume that had long file names, you know, the future of file systems, things that weren't 8.3. But we needed to give a backwards compatibility story for the people who were stuck in DOS. And so this is how we did it. If I dir/x, you can see that I've got this file. This is a long file name. And then I've got this _i_1.txt. So when I write any file, again, even on Windows 10, when I write any file with a quote-unquote long file name, i.e. one that isn't 8.3, not the file system, it's not NTFS's fault. Win32, the open call will actually create another file that is 8.3 compatible. And it's got this crazy naming rules. And so what it does is it basically truncates at 6 characters and adds a ~1. And then keeps the whatever was in the file extension. So I get this _i_1.txt. This is all for fun backwards compatibility with an operating system that hasn't existed in decades. But what I can do is I can create a git ~1, because when git creates that .git directory, it calls, make dir on it, the system will create that backwards compatible 8.3 file name, and it's git ~1. So I can use that as an attack vector too. So the first time we heard about this security vulnerability, when I heard about this anyway, the proposal was basically, let's protect all variations of .git. And we realized very quickly looking at it that that wasn't going to be enough, because Windows does stupid shit still. And again, it's not NTFS's fault. A lot of people go and blame NTFS. The NTFS file system isn't a terrible file system. It's actually pretty good. It's the Win32 APIs that sit on top of it that do all this mangling. So we had to protect against that. We had to look for .git space, git ~1. And thankfully, that was the end of it, at least for Windows. See, Mac OS X actually does have a terrible file system. You can't blame this on its APIs. OS X has a bad file system. HFS Plus does this weird thing where it stores a particular canonicalized form of UTF-8. So if you give it, say, an A with an umlaut over it, it's going to store it in one way, even though that could be represented multiple different ways in Unicode. There's what's called canonically decomposed, which is basically Unicode saying, I want the letter A, and then I want to put an umlaut over that last letter. Or it could be canonically composed, which means I have a literal A with an umlaut as my Unicode code point. So 2 different ways to do it. macOS enforces a single way on HFS+. That's not the end of the mangling that HFS Plus does, though. there are all these fun Unicode code points, like 200C, which is a zero-width non-joiner, 200D, which is a zero-width joiner. These are Unicode code points that aren't printable characters. You can't see them, but they're control codes in Unicode. And when you want to write a file with a name like that on a Mac, and you're using an HFS Plus file system, Mac will just remove them. So you could have any of these sprinkled throughout a folder called .git. So you could have .gi zero-width non-joiner, T, and HFS Plus will happily write into the .git directory. Woof. So it turns out CVE 2014-9390 was actually kind of an interesting problem that we had to dig into and find all the little variations of ways that somebody could get a file into your .git repository. How did we hear about this? Thankfully, through responsible disclosure. We actually heard about it through the Mercurial project. It turns out, I think somebody found this in Atlassian's bug bounty. Atlassian Bitbucket hosts Mercurial repositories. So somebody found this bug in Mercurial because it stores files in .hg. HG is the atomic symbol for mercury. So you could write a file called .hg, all caps, and do the same attack in a Mercurial repository. And so I think they exploited this on Atlassian's bug bounty program. Atlassian went and fixed the bug in Mercurial, realized very quickly, since they also host Git repositories, that it's a vector there. So they alerted the Git security community, and my buddy Pef works at GitHub. He's one of perhaps the lead security guy for the Git project. He told my buddy Vicent, who also works at GitHub, he was then the maintainer of libgit2. Vicent told me, he's like, hey, we've got this patch. It does a stir comp, it does a stir case comp instead of a stir comp. And that's when so I'm the Unix guy, the Mac guy at Microsoft, which is a Windows shop. That's when I kind of lost my mind and realized there are other attack vectors. So we looked at all of these various ways to get in. So it was a great community response, beginning with Mercurial, going to Git, and then libgit2. And because of that, we had these awesome joint releases. So we put out new versions of Mercurial, Git, Git for Windows, libgit2, all at the same time. The Git hosting providers all patched at the same time. So when we announced this security vulnerability, all the major hosting providers, at least GitHub, Bitbucket, and Visual Studio Team Services, were all patched to avoid this vulnerability. So you couldn't Git push a repository that had this in it, so you couldn't use any of us as a vector for this attack. We also patched the Git clients, GitHub Desktop, and Visual Studio, so all were released the same day. We were really happy about that, but we were a little disappointed because there are a lot of people not on this list. One of the really disappointing notable absences is SourceTree, which is Atlassian's Git GUI. The reason this is disappointing is because Bitbucket did get patched. The SourceTree team didn't know about this bug, even though they literally have the desks next to the Bitbucket team. So we realized that maybe we weren't doing a great job of communicating this problem, so we started a new mailing list. And this is how we communicate about security vulnerabilities now amongst each other, which is good, because they keep coming. This is CVE 2017-100. We got to start giving these better names. So this answers the question, can I exploit code on your computer just by making you clone a repository? And the answer is yes. So I'm going to git clone -- recursive, this repo I have, and I put it on a private Git server because everything else is patched. And oh no, calculator opened when I ran clone. Didn't expect that. I really wanted to open up Candy Crush Saga, but I finally figured out how to delete it from my machine, and I didn't want to put it back. Okay, so let me close that. Right. So what have I done? Well, you can see in the output some hints at this, but let's take a look inside the repository. So I've got a repository with nothing in it but a .git modules file. So I've got a Git repository that only has a submodule in it. And if you needed any more reason to avoid submodules, this is one of them. And let's look at my Git modules. Right, so here, so a Git modules file describes how your submodule works. So this is a super repository. This is a parent repository, and it's just got a submodule in it. The submodule name is pwned. That's just a string that talks about, well, the name. It's just metadata. Don't worry about that. And then it's got a path. The path is where it would be checked out into the repository itself. So basically what would happen is when I recursively clone this parent repository, Git will then clone the URL and put it inside, check it out inside the pond directory. And the URL for this repository is ssh://-o proxy command equals calc.exe. Git is written in the Unix philosophy of having small programs that interact with each other and work with other programs on the Unix system, like SSH. So instead of embedding libssh or libssh2, which are great linkable libraries that Git could have chosen to go with, it runs the command line SSH. And it gives it the host name in your submodule configuration to clone. So, you know, if I had http github.com/eThomson whatever, it would run, if I had /github, it would run ssh space github.com. And so here it's running ssh space -o proxy command equals calc.exe. -o is the ssh option configuration. Proxy command is what it will run like a SOX proxy to get out of your network. So this is literally running ssh space -o proxy command equals calc.exe. And ssh is dutifully opening calc.exe. Ouch. I mean, this was an obvious one. We just are very careful about how we handle host names in Git. But it's an important consideration that you can actually run arbitrary commands just by running a recursive clone. And that's very sort of frightening. I expect to be able to clone a repository, and there might be bad code in the repository that I wouldn't want to run or build or anything like that. But I don't expect Git itself to be vulnerable to these sort of problems. Right. Thankfully, that was the last. Oh, no, of course not. We really do need to start giving these better names. So this is 2018-11235. This is actually a 2-week-old exploit that we just patched very recently. Yeah, 2 weeks ago was not my favorite time of this year. Let's go back to my Mac. And this time I'm going to git clone, again, recursively. Again, maybe rethink your use of submodules. So I'm going to git clone -- recursive, again, something on my server because everything else is patched so that I can't host these repositories there. And, oh, yep, there we go. Remote code execution as soon as I clone the repository. This one is a little bit different. It's actually pretty clever. Was really happy to see this, this exploit. So what did we do this time? Well, let's go into the repository. Let's take a look. Right, so I've got that git modules file again. So obviously I have submodules, and I've got this folder called an innocent submodule. Okay, cool. Let's take a look at our git modules. If I type it out, okay, well, right. So clearly I've got 2 submodules, an innocent submodule, and then this one that's got a weird name. Like I said, that name doesn't matter, does it? It's just an arbitrary name, right? So it doesn't matter that it's // modules/evil. Yeah, it might. Let's take a look in our .git folder again. Right, so I've got this modules directory. That's something new now that we have a repository that has submodules in it. And let's take a look inside. Okay, well, I've got this folder called an innocent submodule. And if we look inside that, we'll see that it's got the same structure as our other Git repositories. There's this file called head, there's this directory called objects, and another one called refs. So this is actually the contents of what would be the .git folder of this submodule. Instead of putting it inside the folder space in the repository in its own .git folder, when you clone or add a submodule to a Git repository, it puts that submodule's Git data, the metadata, inside the parent repository's .git folder. Okay. So what I've got is an innocent submodule. But I actually had two submodules listed in my Git modules file, didn't I? I did. So it turns out that submodule name isn't actually so arbitrary after all. The name is actually where Git will create the folder inside the parent's .git repository, and it will use the submodule name as that folder. So if it's //modules/evil, right? So an innocent submodule is here. //modules/evil is my other one. And let's go look at // right, that's the root of my working directory, /modules/evil is a Git repository. Okay. So did Git just clone this submodule there? No, it didn't. It didn't need to. If I take a look at what's in my repository, I've put modules evil into the parent project. So what happens when I run git clone -- recursive, it gets the parent project, it looks at the .git modules file, and then it goes to clone an innocent submodule. And it does that. And then it goes to clone the modules evil. And it looks on disk and says, well, I've already got that. I don't need to bother cloning it because an attacker has bundled that for us and put it right there in the parent repository. So Git looks and says, well, I don't need to do anything. I've already got all the data that I need. That's great. The other great thing is that we've got this modules evil hooks post checkout. So not only were we able to give the repository data for the submodule, we were able to go ahead and configure it with hooks. And again, hooks are just arbitrary programs that we can run, and they should never come from a remote. They should have to be configured manually. Obviously, in this case, it wasn't. So we can look inside our modules evil, and we've got this hooks directory, and we've got a post checkout hook right there. So an attacker was able to give us a hook that runs as soon as we recursively clone it. Okay? And that post-checkout hook, again, this is just AppleScript, but it could have been anything. It could be a Bitcoin miner. It could be rm-rf/. It could be something that tries to get into your corporate network and use this as a foothold, as an attack vector for going through your corporate network and setting up command and control there. So there are a lot of real interesting opportunities for this sort of an attack. So again, this was CVE 2018-11235. And there's a lot more information going into the details on all of these. You can check it out on aka.ms/git security. If you're worried, I can understand. Nobody expects to be running some version control operation and all of a sudden get rooted. But I would comfort you with the idea that these are, first of all, rather arbitrary bugs. They're not subtle. If you see somebody that you don't know opening a pull request in your repository like, hi, please add please merge my pull request. It contains a file called .git/ lots of data, and it's an impenetrable binary mess. You're probably not going to merge that. If somebody comes up to you and says, hi, would you please recursively clone my repository, and gives you some wacky URL from some hosting provider you've never heard of, I'd like to think that you would not do that, right? If somebody comes up to you and says, hi, please run these obscure Git commands, I would encourage you not to do that. So although these are interesting technical vulnerabilities, I find them fascinating. I don't think that they're really the strongest attack vectors for getting into your repository. If I can convince you to run some arbitrary Git command, it's probably easier for me to just give you that Bitcoin miner and have you run it, because it's a social engineering attack either way. That said, of course, the Git community, building Git, building libgit2, building hosting providers, building Git clients, none of us want to be used as that vector. So we're very vigilant about this despite that. Okay? So I would encourage you to always protect yourself. First of all, stay patched. If you're on Windows, please make sure that you've downloaded the latest Git for Windows. Again, this most recent attack was only 2 weeks ago. So we really do encourage you to stay patched, stay updated. That's true for your operating systems. That's true for your IDEs. That's true for Git. Git for Windows is really nice. The most recent versions are actually self-updating, so they'll check to make sure that they're up to date, and if not, they will download a newer version. If you're a Mac user, you get Git bundled with Xcode. Please throw that away. As bad as Apple is about file systems, they're also really bad about developer tools. That Git never gets patched. They've applied some random patches to it before they ship it, and they're bad about giving you the source code for that. So it's not really clear what's in that version of Git. Obviously, you can get it, like they're legally bound to give you that source code, and they will do that. But they're not great about this process. They're not great about updating it. Please use Homebrew or compile it yourself, or whatever. Download a recent binary from somebody you trust, but don't use the version in Xcode, pretty please. If you're on Linux, you probably know, I'm sure you know how to update. That's Debian-based systems use apt. That's great. If you're RPM-based or whatever, that's fine. But please do stay updated. And again, use a hosting provider that you trust. GitHub is very active in security, as is Bitbucket and GitLab. They patched for the most recent one, so did Visual Studio Team Services. So if you're running one of those, the nice cloud-hosted Git providers, great. They'll, as long as it's one of those four for sure, and probably others, check their security policy. We've got you covered. If you're using an on-premises solution, also make sure that you apply the latest security updates. And again, please don't, run arbitrary Git commands. Please do make sure that you are, using common sense security practices. Okay? So that's all I got. Thank you so much. Again, if you are interested in Git, if you're interested in developer tools or security issues, I do have a podcast. You can check it out. It's called All Things Git. And if you have questions for me, I will absolutely hang around after, or if not, you can find me on Twitter. I'm Thomson. So thanks again.